Who among us hasn't dreamed of living forever? Despite numerous debates, the number of people wishing to obtain the elixir of youth does not decrease over time. However, nature has its own laws. Everything has a beginning and an end. This applies not only to the short human lifespan, but also to the existence of massive galaxies and the universe itself. These cosmic giants live incomparably longer than we do, but they too can be newborn, young, aging, and dead. Galaxies go through an evolution. But when did it start? How can we determine their age? And most importantly, why don't we observe the birth of young galaxies anymore? Subscribe now. Since the 1920s, our channel's namesake, Edwin Hubble, the famous American cosmologist and astrophysicist, began studying the evolution of galaxies. They can be born in a burst of brilliance or form gradually, step by step. Yet all evolutionary processes share a set of common mechanisms. Modern telescopes are capable of peering into the very heart of the universe, literally back to the origin of the Big Bang. And what do they find there? The answer is clear. They discover very ancient galaxies whose age is almost equal to the age of the universe. But here's the strange thing. There's an abundance of old galaxies in the macrocosm, while young ones are observed only at enormous distances from us, at the dawn of our universe. Why is that? What prevents the appearance of young galaxies today? Interestingly, the process of star formation is quite accessible for astronomical observation. The most well-known example of a young star cluster is the Seven Sisters, or Pleiades. It's so bright that it can be seen with the naked eye, even in city skies despite light pollution. This cluster has been observed since ancient times and was named after the Greek nymphs, the daughters of the Titan Atlas. The age of this star group is 115 million years, which is essentially adolescence in terms of a human life. It might seem like the perfect setting for observing the birth of a young galaxy, but don't rush to conclusions. In a million years, the cluster might grow and evolve into something larger. Sorry to disappoint. In about 500 million years, most of the stars in the Pleiades will either become black holes, neutron stars, or explode into supernova. As a result, the cluster will be nearly empty, having lost the majority of its stellar population. And in a billion years, it will have no more than a dozen stars remaining. So, are new galaxies being born right now?
In this context, we can cite as an example the processes of merging when two galaxies collide to form one huge one. Let's not forget that our Milky Way, which is about 11 billion years old, will merge in a mad dance with two neighboring galaxies in the future. First, with the Large Magellanic Cloud. This will happen in 2.5 billion years. And then with Andromeda, which is rushing towards us at a speed of 120 kilometers per second. The result will be a giant elliptical galaxy, the Milky Way. But we will not take into account the merger of galaxies, but focus on the formation of new ones. Is it possible to observe this process now? First, it is worth determining by what laws galaxies are formed and evolve. Scientists distinguish three main mechanisms of galaxy evolution: dynamic, spectrophotometric, and chemical. The meaning of the processes occurring during each evolutionary mechanism is clear from its name. The dynamic evolution of galaxies is based on the variability of the movement of their components. Spectrophotometric analysis involves metamorphoses of the spectrum and luminosity of objects, while chemical analysis is based on changes in the chemical composition of the stellar population. How exactly does this information help scientists determine the age of galaxies? The same way we determine the age of stars, based on the laws of their evolution. Luminaries whose properties and parameters are similar to each other go through approximately the same evolutionary path. For example, the age of the Sun, a yellow dwarf located in the center of our planetary system, is currently 5 billion years. Its entire life cycle is twice as long, 10 billion years. The same is true for hundreds of millions of yellow dwarfs throughout the universe. A similar approach is applied to galaxies, but there is a significant difference. Such objects are not uniform. After all, any galaxy contains stars of different types. How then to determine the age of a cluster? The solar system is also a non-uniform object, but we are able to determine its age. Why? The thing is that in this case, all the objects appeared at the same time. By the standards of the universe, plus or minus 500 million years doesn't count. Therefore, it is possible to determine the age of all the participants in the general star formation event. But this does not compare with the large-scale and ambiguous process of the formation of a particular galaxy. Let's answer frankly. Scientists are still calculating the age of galaxies for lack of other reference points, based on the parameters of their stellar population. Therefore, the results are extremely approximate. Even a child can understand this scheme. If the oldest stars in the galaxy have lived for 1 billion years, it is obviously young.
And vice versa. If all the stars are ancient, like relic radiation, then accordingly, the cluster itself has seen a lot. But if everything were so simple, astronomy as a science would not exist. What pitfalls does the voiced approach to determining the age of galaxies conceal? The problem is that not all the stars that we observe in any studied galaxy may belong to it. Sometimes they appear as a result of the process of merging with an older object. So where can we observe the process of formation of young galaxies? The James Webb Orbital Telescope, which has relatively recently begun to fulfill its duties, brought confusion to the scientific community by discovering 2 very young galaxies whose age is 300 million years. All this time, scientists thought that the appearance of such objects in the period almost immediately after the Big Bang was impossible. But James Webb blew to smithereens the foundation on which many theories of modern astronomy were based. Moreover, the famous telescope did not answer our question either, because it discovered young galaxies not in the process of formation, but already formed. Let's look at the problem from the other side. Perhaps we should not judge the age of galaxies only by the stellar population. The behavior of stars in galaxies is subject to a certain general rule. What if, in addition to the stars in the center of the cluster, there is something more massive and large-scale, around which all this fuss is happening? There is much more of this unknown substance than the stars themselves. So maybe it appeared before them, and the age of galaxies should be calculated based on the parameters of this substance. We mean the dark matter that fills the universe and the galaxies themselves. But here there is a discrepancy. In this case, it is logical to assume that even now clots of dark matter can contribute to the formation of young galaxies. Where did the clusters of mysterious, invisible dark matter come from? This happened at the beginning of the formation of the universe. And, according to many theories, it was the clots or halos of dark matter that became the birthplace of the first galaxies. Now any schoolchild knows The heavier and denser the object, the stronger its gravity. So the clusters of dark matter were heavy enough to attract ordinary matter, thereby increasing the mass even more. Gradually, the gas, cooling down, began to form proto-galaxies. But what if dark matter is one of the scientific legends? After all, it is extremely difficult to study it even indirectly.
However, the fact that stars gather in groups called galaxies and are not just scattered chaotically across the canvas of space is one of the proofs of its existence. It is difficult to argue with the fact that the world is changing. Our ideas about the theories of galaxy evolution are also changing. At the moment, the hierarchical concept is the most recognized. According to it, galaxies began to form and evolve simultaneously, and this process was initiated by the condensations of cold, dark matter, which we talked about earlier. The cloths were small, gradually condensed, and, under the influence of gravity, united into large conglomerates. The theory is also confirmed by computer simulations. Of course, there are shortcomings in this scenario. But despite its imperfections, the hierarchical concept is currently a fundamental theory explaining the evolution of galaxies. But how can we explain the fact that we are not currently observing the birth of new galaxies? After all, dark halos have not disappeared anywhere. Yes, they still exist, but the time of active galaxy formation is gone forever. Let's not forget that the universe is moving towards its heat death or some other sad ending. That is, galaxies are gradually moving away from each other due to the expansion of space. What is the heat death of the universe, or the Big Freeze? This is the state of maximum entropy that any physical system that does not exchange energy with others tends to. The heat death of the universe can be compared to the gradual fading caused by the divergence of galaxies. If the macrocosm really strives to this state, then what kind of birth of new star clusters can we talk about? But there is hope, because the process of formation, although it has slowed down, has not yet stopped. Individual luminaries are still being born. These are not empty words intended to scare you. If you pay attention to the graphs of birth of new stars, from the Big Bang to the present moment, you can see that the process was much more active earlier. This situation is also observed because the substance that stars are made of is becoming less and less. It is being absorbed by active black holes. Because of this, an extremely small number of young galaxies are being blown away, where active star formation processes could theoretically take place.
Not to mention, Partagus's theory dominates over others. The ship, called the universe, is confidently moving towards the end. However, there will come a moment when not only galaxies, but also new stars will stop appearing, and the universe will become empty. At such moments, a person does not dream of eternal life, but on the contrary is glad that he will not live to see such a sad ending to our global world. But do not despair, we still have several 100 billion years in reserve. Well, Earthlings, this is not the end of the video. Ahead of us are still very interesting and simply enchanting topics. Further, the person of the universal expanses could delight you with all. I need feedback. It can be expressed quite simply. You just need to put an electronic like under this video, because we simply do not have other likes, and continue the phrase, "I know." In this way, you will make it clear that we are moving in the right direction. Don't switch.